Hello and welcome to this video of getting started with Atmel Studio. In this video, we are going to create a simple project using Atmel Studio and test it using simulation environment like Proteus. So let's go ahead. This is Atmel Studio. Atmel Studio is used for developing embedded applications for Atmel 8-bit and 32-bit controllers. So open Atmel Studio. It will take some time. We can see the start page. Here are some links for user guide and tool helps and latest news. We can see here new project and new example project buttons and some recent project. We will create a project. So here we can see the main menu, file, edit, view and other options. So click on the file, new and then project. Now we can see the new project window with installed templates like C and C++ and assembler. We can select this option to create assembly language project for 8-bit controllers. In this video, we are going to create a project using C language. So select this option, GCC C executable project. Okay, we can give name for this project. So we'll give it as LED. Okay, as we are going to blink the LED in this project. Here we can see the path to project. Click on browse. I will store it on my desktop. So I will create a new folder like demo project. So I will choose this folder. Okay, and click on OK. It will take some moment. Okay, as you can see, the device selection window will appear here. You can see the list of various controller over here. Okay, and we can choose our device by scrolling down, or better way is that we can type it over here. So we are going to blink LED using Atmel 16. So I will choose Atmel 16. Okay, we can see here Atmel 16 and different links for Atmel 16 here, datasheet and other tools. So just select the Atmel 16 and click on OK. It will take some moment to open the project window. So we can see the project window opened here. This is editor. In that editor, some lines of code is already here. That is include file avr/io. In this file, all registers of Atmel 16 or our device are defined. So this is the main function while one loop. And we can see here solution explorer. We can find our file led.c here and libraries over here. Okay, let's go ahead and write down the code. Assume that we have connected LEDs to the port B. So we have to make port B as output. So in data direction register, we have to put value FF. Okay, in while main loop, we'll write code. First we will port B, we'll make it high. Okay, then we have to give some delay millisecond. Okay, we will give it 300 millisecond. Then again we have to make port B low. Again we have to give some delay. Okay, we are connecting our LEDs in common anode fashion. So after making port high, LEDs will be turned off. LED is off. Okay, and after making it low, okay, I'm sorry, here we have to make it 0 actually. It will turn on LED. Okay, and we have used this delay function which by default in Atmel Studio. So we have to include library file for this function, which is in utility #include utility and delay.h. Okay, so now we can build our project by using this button or we can go simply in build menu and build solution. We can observe status of our building in output window. Oh, we got a warning that ep_CPU is not defined. So we have to define it. So #define f_CPU. So we are going to use I will use 8 MHz, which is inbuilt clock in the controllers. So I will select here 8 MHz. 8 MHz. We have to define the exact value of the CPU frequency. Otherwise, this delay will mismatch. So we have to take care according to that. We can change our frequency by using fuse bit. We will see it later. So then I can go ahead and compile it. We can compile by clicking on this button. Okay, now complete. It is successful without any warning or error. Okay, now we can see the output file in this. Okay, led.hex. So this is the file which will be flashed into the controller. Let's go ahead and simulate it. Okay, we will simulate our code using Proteus software. In Proteus software, we have to place our components. So select this component mode and then click on this button. We need Atmel 16, so type it over here, Atmel 16. Okay, we can, after clicking on this, you can see here pin diagram for Atmel 16 and its PCB footprint. Click on OK. Okay, so this is Atmel 16. We need some LEDs to interface. So LED in optoelectronics, we can find animated LEDs, active animated LED. So I'll select blue one. Okay, it will take some time to arrange all the LED and connect it to the port P. Okay, in this way we have connected all LEDs to the port B. We have to put hex file in this controller, so double click on it, click on browse option, go on the desktop and then our demo project, go in it, debug and hex file. Okay, we have provided program file path, that is hex file. Clock fuse, we used 8 MHz, so select this option and all other rest option put at it is. Click on OK, then click on play. So we can see these LEDs are blinking and here we can see it is changing its status, means port are going high and low. If you see the port is low, the green indicates low, actually it is blue indicates low and this is high. When it is high, it will indicate in a red color and LEDs are off. Okay, so it is on and off. Okay, let's go ahead and try to give it small delay like 200 millisecond. Okay, and then compile it, build it. Okay, and then so now it is blinking more fast. This is simulation time, but the actual simulation time you can observe over here. In this way we can create a project, we can create more amazing things using Atmel Studio and test it or simulate it in the Proteus. To get more detailed information and project file of this Atmel Studio and the simulation file, you can find it the link below which I have added. Thank you for watching this video.